I'm going to go over the rational roots theorem, something that you've probably seen in pre-calculus. Rational roots theorem helps us to find zeros of polynomials, which can be very difficult to find. So if we have a function f of x equal 2x cubed minus 7x squared plus 4x plus 3, any rational root is going to be of the form p over q, where p is the divisor of the constant coefficient and q is the divisor of the leading coefficient. So the divisors of 3 are plus or minus 1, plus or minus 3. Those are the integers that go into 3. And for the leading coefficient, we really only need the positive divisors. Numbers that go into 2, the leading coefficient, the positive numbers that go in there are 1 and 2. And so then the possible rational roots, if q is 1, we're dividing these numbers by 1, we get the same numbers back, plus or minus 1, plus or minus 3. And if we divide by 2, we're also going to get plus or minus 1/2, plus or minus 3/2. So any rational root, rational means fraction, is going to be one of these numbers here. And then we can check to see which of these work. The quickest way to check is to do synthetic division. Remember, we did long division before. When we did long division, there was a lot of duplication in our work. If I can give that example again. Pull up that example here. So, in long division, first of all, we're changing the sign. We can determine the exponent of x by its position. We can just like we have placeholders in the decimal system, we know the power of 10 by the position. So we don't really need to write the x's on each step. And also, we don't really, if we change the sign once at the beginning, we don't need to change the sign on each step. And also, we don't need to write 2 twice. We don't need to write -1 twice here. So there's a lot of duplication there. And so if your divisor is the form x plus a number or x minus a number, you can do what's called synthetic division, and that's what we're doing here, the synthetic division. So I'm writing just the coefficients of the polynomial, 2, minus 7, 4, and 3, and I know the power of x by its position, and I'm just writing the divisor, the numerical part of the divisor, but with the opposite sign. So the rest of it is just multiply, add. So bring down the 2, multiply by 1 is 2, and then add. -7 plus 2 is -5. -5 times 1 is -5. 4 plus -5 is -1. -1 times 1 is -1. 3 plus -1 is 2. And we're looking for remainder 0. As soon as we get remainder 0, we know that that's going to be one of the roots. And it takes us some work, but finally down here, we find that if the divisor is, if the root is 3/2, we actually get remainder 0. So you bring down the 2, multiply, the 2's cancel, that leaves you 3. -7 plus 3 is -4. 2 into -4 goes -2. -2 times 3 is -6. 4 plus -6 is -2. The 2's cancel, but not the minus sign, and then you'll have a -3. 3 minus 3 is 0. And then you can put the x's back in. And this work up here is also serves a double purpose. It also will help us later when we plot the points to sketch the graph. We know that f of 1 is going to equal 2, f of -1 is equal to -10, and so forth. So we're not done with this information here. We can still use this information when we sketch the graph. So if we put the x's back in, we see that x is equal to 3/2, or 2x squared minus 4x minus 2 equals 0. And we can try doing synthetic division on this again. but this one doesn't have any rational roots. So then we go to the quadratic formula and plug in the numbers here. So we have x equal 3/2 or 2x squared minus 4x minus 2 equals 0. And we want to identify a, b, and c. A is the coefficient of x squared, b is the coefficient of x, c is the number by itself. And the quadratic formula, x equal minus b plus or minus square root b squared minus 4ac all over 2a. So this is going to be minus a negative 4 plus or minus square root negative 4 squared minus 4 times 2 times negative 2 all over 2 times 2. Double negative is positive, so it's 4 plus or minus square root of negative 4 squared is 16. 4 times 2 is 8, times 2 is 16. Negative times negative is positive. 2 times 2 is 4. We got this as square root of 16 times 2. 16 plus 16 is 16 times 2. And then as long as you don't have more than one minus sign, the square root of product is the product of the square roots. And square root of 16 is 4. 4 plus or minus 4 root 2 over 4. We can distribute the denominator. 4 over 4 plus or minus 4 root 2 over 4. The 4's cancel. We'll have 4 plus or minus root 2. Root 2 is approximately, for purposes of graphing, it will help to estimate root 2. It's approximately 1.4. 1 plus or minus 1.4. 1 plus 1.4 is 2.4. 1 minus 1.4 is negative 0.4. So we have an approximate, approximately equal here for purposes of graphing. Okay, so then we can plot the points, and we have the 3x intercepts here, and we need to, it's good to plot some points on either side of the intercepts to get the full shape of the graph. And most of this information was we already computed when we did the synthetic division, and I think 2 we didn't do with synthetic division, but if you plug in 2, you can get a value there. I wanted some number between 3/2 and 2.4, so I wanted to put a 2 in there to get the full shape. So then we plot the points and connect the dots. So that's that gives us the graph, and that concludes this presentation. Actually, I'll say a little bit more. We're a little bit later in this semester, we're going to be computing the slopes, and we see that we have a positive slope, slope 0, and then negative slope, and then slope 0, and then positive slope. And later in the semester, we're going to be computing the derivatives, which is essentially a slope function that'll give the slope at each point, and that's going to enable us to more precisely determine these local maximum and local minimum values here. So anyway, that's a harbinger of things to come. And that concludes this presentation.